Hey there, ready to dive in?
Absolutely.
We're tackling blockchain development with Rust today,
Cool.
pulling out the most fascinating insights from your source material,
Sounds good.
so you can really get a handle on this rapidly growing space.
Yeah, it's a perfect pairing, really,
Right.
when you consider the need for security and efficiency in blockchain tech.
Right, you've been digging into Rust for blockchain application development,
Yeah.
which is awesome,
Mm-hmm.
especially considering how important secure voting systems are to you.
Right.
That book can get pretty dense, though, so
Sure.
luckily, expert speaker is here to help us unearth those golden nuggets.
Let's do it.
Let's unpack this, starting with the big idea.
Okay.
Why Rust for blockchain development in the first place?
It all boils down to Rust's memory safety features
Okay.
and impressive speed.
Okay.
Think of it like this.
Yeah.
C++ allows you to build these intricate systems,
Okay.
but it's like juggling chainsaws without a safety net.
Oh.
One wrong move, one memory leak, and the whole thing can come crashing down.
Right.
Rust is like having that safety net
Okay.
built right into the language itself.
Okay, I get the analogy.
Yeah.
But what do those memory errors actually look like
Sure.
in a language like C++?
Yeah.
Paint me a picture.
Imagine you're writing code to manage a list of transactions,
Okay.
kind of like a digital ledger.
Right.
In C++, you have to manually allocate and deallocate memory
Yeah.
for every single transaction.
Wow.
If your code accidentally tries to access a piece of memory that's already been freed up,
Mm-hmm.
that's a use after free error.
Okay.
And it can lead to crashes or even security vulnerabilities.
Oh, no.
Rust's ownership system completely sidesteps this
I-
by making sure that only one part of the code can own a piece of memory at any given time.
So Rust is like that super organized librarian
Exactly.
who always knows where everything is.
Yes.
And make sure you're following the rules.
Yep.
No more misplaced books or memory leaks.
Exactly.
Right.
And this level of reliability is absolutely critical. Yeah.
For blockchain technology, because
Yeah.
we're talking about systems that need to be incredibly robust and resistant to errors.
And speaking of robust systems, the book mentions how Windows rewrote their entire kernel using Rust.
Wow.
And get this, in under 200,000 lines of code.
That's incredible.
Kind of makes you wonder if Rust is some kind of coding superpower.
It really is a testament to how powerful and efficient Rust is.
Yeah.
It's like building a fortress,
Mm-hmm.
but with code.
Right.
And that fortress is what underpins so many digital interactions these days.
Okay, color me impressed.
Sure.
But there's one concept in Rust that still trips me up a bit.
Okay.
The ownership model.
Right.
The book explains it,
Yeah.
but the examples always feel a bit abstract.
Sure.
Got a real-world way to wrap my head around it.
Think of it like borrowing a library book.
Okay.
You can borrow it,
Okay.
read it,
Mm-hmm.
even jot down notes in the margins.
Right.
But you can't just rip out a page and give it to a friend.
Right. Right. You have to return the book so someone else can borrow it.
I think I'm starting to see it.
Yeah, okay.
So the book is the data,
Yeah.
and I'm the function trying to use it.
Yeah.
And Rust is the very strict librarian, making sure nobody is breaking the rules and messing up the system.
Precisely. And that borrowing system
Okay.
is key to how Rust avoids those nasty memory errors we were talking about earlier.
Okay, let's shift gears a bit and unpack this whole proof of work versus proof of stake thing.
Okay.
It seems like proof of stake is the new kid on the block,
Right.
but the book mentions it could potentially lead to more centralized power in the wrong hands.
Right.
What are your thoughts on that?
That's a crucial question.
Yeah.
And it gets to the heart of the trade-offs inherent in different consensus mechanisms.
Okay.
Proof of work, which Bitcoin uses, is
Yeah.
like a giant energy-intensive competition to solve complex math problems.
Okay.
It's incredibly secure,
Hmm.
but also slow
Right.
and consumes a massive amount of electricity.
Yeah, I've heard about that.
Yeah.
It's like keeping a stadium lit up 24/7 just to power Bitcoin transactions.
It is incredibly resource-intensive.
Wow.
Proof of stake, on the other hand,
Okay.
is more like a voting system
Okay.
based on how much cryptocurrency you own.
Yeah.
The more you own, the more voting power you have when it comes to validating transactions and adding blocks to the chain.
Okay.
It's far more energy efficient and can handle a lot more transactions per second.
So that's why Ethereum made the switch to proof of stake.
Exactly. They were facing some serious scalability issues,
Right.
and the energy consumption of proof of work was a growing concern for them.
Yeah.
The switch to proof of stake, often called the merge, was a massive undertaking,
Wow.
but it's already having a significant impact on their network's efficiency.
It makes sense, though.
Yeah,
A more efficient, eco-friendly way to keep the blockchain humming along.
right.
But going back to my earlier question,
Yeah,
what about the centralization risks with proof of stake?
right.
The book touched on that a bit.
Yeah, it's a valid concern.
Yeah.
Because proof of stake relies on staked coins for validation,
Hmm.
there's a theoretical risk that a small group of entities with large holdings could potentially gain undue influence over the network.
Right.
This is a topic of ongoing debate and research in the blockchain community,
Sure.
and there are various proposed solutions being explored, such as implementing more robust governance mechanisms and encouraging greater decentralization of staking pools.
Okay, so it's not all sunshine and roses with proof of stake.
Right.
There are some potential downsides to consider, and it'll be interesting to see how these solutions evolve.
Absolutely. It's all about balancing security, scalability, and decentralization,
Right.
which is no easy feat.
Right.
It's a fascinating area of ongoing development.
So we've gone from memory safety to the energy consumption of algorithms. So it's quite a range.
It is quite a range.
I'm ready to dive into the world of applications built on top of this technology, like dApps.
Okay.
What are some of the things that really excite you about building dApps with Rust?
One word, potential. Imagine a world where you could cast a vote online without having to worry about your information being compromised or manipulated.
Yeah.
Secure voting systems built on blockchain technology could revolutionize our democratic processes.
Wait, seriously?
Oh, yeah?
Secure voting systems are actually feasible with this technology.
Absolutely.
I'm picturing a future where we don't have to worry about ballot box tampering or those long lines at polling places.
That's it. Tell me more.
We're talking about a future where we can track votes on an immutable ledger.
Wow.
Every vote, every transaction
Hmm.
is recorded and verifiable,
Okay.
making it incredibly difficult for malicious actors to interfere with the process.
Okay, that's huge.
Yeah.
I'm starting to see why everyone is so excited about the potential of dApps.
Yeah,
But this book throws a lot of blockchain names at us.
it does.
Ethereum, Solana, Polkadot.
Hmm.
It's like a whole new world.
Right.
Got any tips for figuring out which ones matter for someone like me who's just starting out?
It can definitely feel overwhelming with so many options.
Yeah. A good starting point is to focus on the problems each blockchain is trying to solve.
Okay.
Are they prioritizing speed and scalability like Solana?
Okay.
Do they focus on interoperability like Polkadot, which allows different blockchains to seamlessly interact with each other?
So it's like choosing the right tool for the right job.
Exactly.
You wouldn't use a wrench when you need a screwdriver.
Exactly. Each blockchain has its own strengths and weaknesses,
Mm.
and understanding those is crucial for building successful and efficient dApps.
That makes a lot of sense.
Yeah,
It's all about picking the right platform that aligns with the goals of your project.
right.
But before we move on,
Yeah.
let's circle back to something you mentioned earlier.
Okay,
Rust being used for more than just cryptocurrency.
right.
What other sorts of projects are being built with it?
Oh, tons.
Okay, like what?
Rust's reputation for speed, safety, and reliability has made it a popular choice for a wide range of applications.
Give me some examples.
We're talking everything from web browsers like Firefox to operating systems and game engines.
Wow.
It's even being used in machine learning tools.
Wait, really?
Yeah.
I had no idea Rust was being used in so many different fields.
It's true. And its popularity is only going to continue to grow as more industries embrace cutting-edge technologies that demand performance and reliability.
This is already making my head spin,
Yeah.
but in a good way.
Yeah.
I feel like we've only just scratched the surface of what's possible with blockchain and Rust.
We've definitely covered a lot of ground.
We have.
But you're right, this is a field with endless possibilities.
Yeah.
And knowing Rust gives you a significant advantage in navigating this ever-evolving landscape.
It sounds like we're just getting started.
We are?
So we've covered why Rust is a good fit for blockchain, touched on the complexities of consensus mechanisms, and even explored the exciting world of dApps and their real-world applications.
We have.
What's next on our blockchain adventure?
Well, since you're interested in building secure voting systems, I think it's time we delve into the intricacies of smart contracts,
Okay.
which are essentially the self-executing agreements that power many dApps.
Smart contracts, you say?
Yes.
That sounds intriguing.
Yeah.
Let's dive in and see how these self-executing agreements work.
Let's do it.
All right, expert speaker, you've piqued my curiosity.
Sure.
Let's talk smart contracts.
Okay.
I understand they're like self-executing agreements,
Right.
but I'm still a bit fuzzy on the details.
Sure.
What exactly are they,
Okay.
and how do they work?
Think of smart contracts as digital agreements
Okay.
written in code
Mm-hmm.
that automatically enforce the terms when certain conditions are met.
Okay.
They're like vending machines for agreements.
Yeah.
Put in your input,
Right.
meet the pre-programmed conditions,
Mm-hmm.
and the contract automatically executes the agreed-upon outcome.
Okay, that's a helpful analogy.
Yeah.
So instead of relying on a third party like a lawyer or a bank to ensure everyone holds up their end of the bargain, the smart contract itself handles it all.
Precisely. This makes transactions more efficient, transparent, and secure.
Okay.
Plus, because they live on the blockchain,
Right.
they're tamper-proof and accessible to everyone involved.
That's fascinating.
Yeah.
Can you give me a concrete example
Sure.
of how a smart contract might be used in, say, a secure voting system?
Absolutely. Imagine a voting dApp
Okay.
built on a blockchain like Ethereum.
Mm-hmm.
A voter could cast their vote,
Right.
and that vote would be encrypted and recorded as a transaction on the blockchain.
Okay.
The smart contract would be programmed to verify that each vote is legitimate coming from a registered voter and prevent things like double voting
Right.
once the voting period ends.
Right.
The smart contract could automatically tally the votes and announce the results,
Okay.
all without the need for manual counting or the possibility of manipulation.
Wow. It's impressive.
Yeah.
It sounds like smart contracts could really revolutionize the way we think about agreements and transactions.
They have the potential to completely transform industries.
Okay.
But before we get carried away,
Right.
let's take a step back and look at how these smart contracts are actually created.
Okay, so how do you create a smart contract?
It starts with choosing the right blockchain platform to build on.
Okay.
Each platform often has its own preferred programming language for smart contracts.
Right.
Ethereum, for example, uses a language called Solidity.
So it's like learning a whole new language just to write these digital agreements?
Yeah,
That sounds like a challenge.
it can be, but luckily many of the core concepts you already understand from traditional programming translate quite well.
Okay.
Plus, there are tons of resources available online to help you get up to speed.
That's reassuring.
Yeah.
So let's say I've chosen my platform and learned the lingo.
Right.
What's the next step in bringing my brilliant smart contract idea to life?
Then it's time to get your hands dirty with some code.
All right.
You'll design the logic and structure of your smart contract, defining things like the parties involved, the terms of the agreement,
Right.
and the conditions that need to be met for the contract to execute.
And this is where Rust's security features come into play, right?
Exactly.
We want to make sure these smart contracts are ironclad and resistant to any vulnerabilities.
Exactly. When you're dealing with valuable digital assets and sensitive data, security is paramount.
Right.
Rust's focus on memory safety and preventing common programming errors makes it an excellent choice for building robust and reliable smart contracts.
This is really fascinating stuff.
Yeah.
It's amazing to think that these lines of code can have such a real-world impact, from revolutionizing voting systems to automating complex financial transactions.
It truly is a testament to the power of blockchain technology and the ingenuity of the developers who are constantly pushing the boundaries of what's possible.
Speaking of pushing boundaries, one area I'm particularly interested in is decentralized finance, or DeFi.
Right.
I know it's one of the hottest areas in the blockchain space right now. Can you tell me more about what DeFi is and how it's being used?
Think of DeFi as a way to recreate traditional financial services, like
Yeah.
lending, borrowing, and trading,
Right.
but without the need for intermediaries like banks or brokers.
Okay.
It's all about empowering individuals and giving them more control over their finances.
Okay, so it's like taking the power back from the big institutions and putting it in the hands of the people.
Exactly. With DeFi, you can lend your crypto directly to others and earn interest.
Wow.
Borrow crypto against your holdings,
Yeah.
or even trade cryptocurrencies without going through a centralized exchange.
That sounds incredibly empowering,
It is.
but is it safe?
That's a valid concern.
Yeah.
As with any new technology, there are risks involved.
Right.
Some DeFi platforms have been targeted by hackers,
Right.
and there have been instances of vulnerabilities being exploited.
Yeah.
However, the DeFi space is constantly evolving and maturing, with developers constantly working to improve security and address vulnerabilities.
So it's important to do your research and choose reputable platforms with a strong track record of security.
Absolutely. It's also crucial to understand the risks involved and to only invest what you can afford to lose.
Right.
But despite the risks, the potential of DeFi is enormous.
I can see why people are so excited about it.
Yeah.
It has the potential to democratize finance and make financial services more accessible to people around the world.
Precisely. It's a fascinating space to watch,
Yeah.
and I'm excited to see what innovations emerge in the coming years.
So we've gone from the nuts and bolts of smart contracts to the revolutionary potential of DeFi.
We have.
I'm eager to learn more about actually building these dApps
Yeah.
and see how we can bring these concepts to life with code.
Okay.
What are some of the key things to keep in mind when designing and building a dApp?
Building a successful dApp requires careful planning and consideration of several factors.
Okay.
It's not just about writing code.
Right.
It's about understanding the unique challenges and opportunities of the decentralized world.
Okay, so what are some of these unique challenges and opportunities we need to be aware of?
One of the biggest challenges is scalability.
Okay.
Many blockchain platforms like Ethereum are facing scalability issues as the number of users and transactions grows.
Right.
This can lead to slow transaction speeds and high fees.
Right. I remember you mentioned that earlier when we were talking about Ethereum switching to proof of stake.
Yes.
So how do developers address these scalability issues when building dApps?
There are a few different approaches.
Go ahead.
One is to choose a blockchain platform that is designed for scalability from the ground up,
Okay.
such as Solana,
Right.
which is known for its high transaction throughput and low fees.
So it's like choosing the right size engine for your car,
Exactly.
depending on how fast and how far you need to go.
Another approach is to optimize your dApp's code to minimize its impact on the blockchain.
Okay, that makes sense.
Yeah.
So scalability is one big challenge. What else do we need to keep in mind?
Security is paramount. When you're building a dApp that handles valuable assets or sensitive data, security is absolutely crucial.
That's a given. Any tips for ensuring the security of our dApps?
It's essential to follow security best practices throughout the entire development process, from designing your smart contracts to writing your front-end code.
Right.
Thoroughly testing your code both manually and with automated tools is also essential.
So no cutting corners when it comes to security. What else?
User experience.
Okay.
While dApps offer many advantages over traditional applications, they can also be more complex and difficult to use.
Right.
It's important to design your dApp with user experience in mind, making it as simple and intuitive as possible for users to interact with.
Right, because if it's too complicated, people are just going to give up and go back to using whatever centralized platform they're used to.
Exactly. It's all about finding that balance between leveraging the power of decentralization while still providing a user-friendly experience.
This is all incredibly insightful. Expert speaker.
Okay.
I feel like I have a much better understanding of the opportunities and challenges of dApp development now.
I'm glad to hear it. It's an exciting field to be a part of.
Yeah.
And I'm constantly amazed by the innovative dApps that developers are creating.
I'm ready to get my hands dirty and start building.
Okay.
But before we fire up our code editors,
Sure.
let's take a quick break to gather our thoughts and prepare for the coding journey ahead.
Sounds good.
Okay, we've covered a ton of ground.
We have.
From the why of Rust to the how-to of smart contracts.
Right.
But I have to ask, now that we're ready to actually build,
Yeah.
are there any tools or frameworks that can make this whole dApp development process a bit smoother,
Oh, absolutely.
maybe even enjoyable?
The dApp development landscape is bursting with tools and frameworks,
Okay.
each with its own strengths and specialties.
Right.
Think of it like stocking your workshop.
Okay.
You want the right tools for the job.
I love that analogy.
Right.
So for someone just starting out, what tools would you recommend adding to their dApp development toolbox?
Well, if you're diving into the Ethereum ecosystem,
Okay.
a great starting point is Truffle.
Okay.
It's a development environment that's like a Swiss Army knife for dApp developers.
Okay, tell me more about this Truffle toolkit.
Sure.
What makes it so powerful?
Truffle comes with everything you need to write, test, and deploy your smart contracts.
Wow.
It even provides a local blockchain environment called Ganache,
Okay.
so you can experiment without spending real ether on gas fees.
So it's like having a blockchain simulator right on your computer.
Exactly.
You can test out your dApp in a safe environment before launching it into the real world.
Exactly. And for those inevitable debugging moments we all face,
Right.
there's Hardhat.
Okay.
It's known for its debugging tools, which are a lifesaver when you're trying to track down those elusive bugs in your smart contracts.
Okay, these tools sound incredibly helpful for navigating the world of Ethereum development.
Yeah.
But what about those other blockchain platforms we discussed, like Solana and Polkadot?
Sure.
Do they have their own set of specialized tools?
Absolutely. Solana has a fantastic framework called Anchor.
Okay.
It's designed to simplify the process of building secure and efficient dApps on the Solana blockchain.
Right.
It handles a lot of the boilerplate code for you, which can be a huge time saver.
So it's like having a sous chef in the kitchen,
Yeah.
taking care of those repetitive tasks so you can focus on the creative culinary magic.
I like that analogy. Anchor allows you to concentrate on your dApp's unique logic and functionality,
Right.
leaving the underlying complexities of interacting with the Solana blockchain to the framework.
That's awesome.
Yeah,
And what about Polkadot?
sure.
It's known for its interoperability features, allowing different blockchains to communicate with each other.
Right.
What tools are popular in that ecosystem?
Polkadot has Substrate,
Okay.
a powerful and versatile framework that actually lets you build your own custom blockchains.
Hold on, build your own blockchain. That sounds incredibly ambitious.
It can be, but Substrate makes it surprisingly approachable.
Okay.
It provides pre-built modules and components that handle a lot of the heavy lifting,
Right.
so you can focus on designing the unique features and functionalities of your blockchain.
Wow. That's incredibly powerful.
It is.
It seems like we have an abundance of tools and resources at our disposal,
We do.
no matter which blockchain platform we choose to build on.
That's right.
Absolutely. And this is one of the most exciting aspects of the blockchain space.
Yeah.
The community is incredibly collaborative,
Mm-hmm.
and there's a constant stream of new tools, frameworks, and resources being developed and shared.
Absolutely.
That's really inspiring.
Yeah.
So we've got our tools, we've got our roadmap.
Right.
But before we wrap up,
Okay.
I want to circle back to a topic that's been woven throughout our conversation.
Sure.
Security.
Of course.
It's clear that security is paramount when building dApps.
Yes.
But are there any parting words of wisdom you can offer to help us navigate this critical aspect of development?
You're right. Security should be front and center throughout the entire development process,
Right.
not just an afterthought.
Right.
One key piece of advice is to always be aware of the potential vulnerabilities in your code.
Okay, so stay vigilant.
Yes.
What are some common pitfalls that developers should watch out for?
One of the most common vulnerabilities is called a reentrancy attack.
Reentrancy attack. That sounds a bit intimidating.
It can be, but understanding how they work is the first step in preventing them.
Okay.
Essentially, a reentrancy attack occurs when a malicious actor manipulates your smart contract
Okay.
into executing a function multiple times,
Right.
potentially draining its funds or disrupting its operations.
So it's like tricking the smart contract into repeating an action over and over again,
Yeah.
like hitting the withdraw funds button multiple times before the system can catch up.
That's a great way to think about it.
Okay.
And thankfully, Rust's design and security features can help mitigate these risks.
Okay.
Its strict ownership rules and borrowing system make it far more difficult for attackers to exploit these kinds of vulnerabilities.
Okay. That's reassuring to know.
Yeah.
So by carefully considering our code and leveraging Rust's security features,
Right.
we can build more resilient dApps.
Absolutely.
Any other security tips you want to emphasize before we wrap up?
Testing. I can't stress enough how important thorough testing is.
Right. We've covered that.
Yes.
Unit testing, iteration testing.
Yes.
Make sure every line of code is put through its paces.
Exactly. And don't just rely on automated tests.
Okay.
Manual code review is also crucial.
Right.
Having another set of eyes scrutinize your code can often uncover vulnerabilities that automated tests might miss.
So it's like having a second set of eyes proofread an important document before you hit send.
Precisely. And as your dApp grows in complexity and you start interacting with external libraries or third-party services, those security considerations become even more critical.
This has been an incredible deep dive expert speaker. And thank you for sharing your insights and expertise with us today.
My pleasure.
I feel like I've gained a solid understanding of not just the technical aspects of blockchain and dApps,
Right.
but also the incredible potential of this technology to shape the future.
Yeah, it's exciting stuff.
And for our listeners who are eager to take the next step in their blockchain journey,
Yes,
remember that the resources are out there.
they are.
Dive into the documentation. Explore those tools and frameworks we discussed.
Yes.
And don't be afraid to experiment and ask questions.
Right.
The blockchain community is incredibly welcoming and supportive.
I couldn't agree more. The more people we have exploring and building on blockchain, the brighter the future of this technology becomes.
So as we wrap up this episode of The Deep Dive,
Okay.
we want to leave you with a final thought.
Right.
The future is being written in code.
It is.
And with Rust and blockchain, you have the power to shape that future.
You do.
What will you build?